So take a look. We have a seesaw, okay? And there are three masses that are hanging from there. Okay, mass 1, mass 2, and mass 3. And the masses are 55, 35, and 10 kilograms each. And also it says, consider the lever arms to be, lever arm 1 is 4 meters, lever arm 2 is 1.5 meters, and lever arm 3 is 4.5 meters. Okay. So the instruction is, the first one is draw a free body diagram. So right now I'm going to focus on that step, to draw a free body diagram. Now, in free body diagrams, I should be able to see all forces involved in the system. All the forces that are involved. Now, how many forces I have in this exercise? How many forces I have in this exercise? Remember, they are not giving me forces in this moment. They are giving me masses. Now, what is the force that is related to the masses of an object? I repeat the question. What is the force that is related or that depends on the mass of an object?
The lever arm.
No, the lever arm is a distance. Right now I'm talking about a force.
The weight.
The weight, okay? Mass is a measure of how heavy or how light something is. But that's not a force, because remember, the forces are measured in newtons, okay? So what we have to do in the first place is, from the masses, we need to get all the forces, okay? In this case, this will be force 1, this will be my force 2, and this will be my force 3. Now, I will put the information in the sketch. My object 1, that object is going to, it represents one mass, and it is the mass 1, which is 55 kilograms. My mass 2 is 35 kilograms. And my mass 3 is 10 kilograms. Okay. And then we have the information from the table. Then we have the information from the table. The lever arm 1, that is 4 meters. The lever arm 2, that is 1.5 meters. And then we have the lever arm 3, that is 4.5 meters. Okay, that is the information given for the exercise. Now, I need to work on the first step, which is draw a free body diagram. This is going to be my first step. Draw a free body diagram. So what we do is we're going to represent all the drawing in a simpler one. And before we continue, I want you to tell me what is the hinge in this seesaw? What is the hinge in this seesaw? Remember that the hinge is the place that is not rotating, okay?
The one in the
In
middle.
the middle.
It is in the middle, okay? Yes, it is in the middle. So this, it's going to be the hinge. I'm gonna do it in different color, okay? This is going to be the hinge. Now, after this, what you do is you start doing the free body diagram. So what I'm gonna do now is I'm gonna make it simpler for you. Okay, there it is. I have the bar over there, okay? And I will represent the hinge with a circle. Okay. No se mira muy bien, honestly. Okay, but I'm gonna do it like this. Okay. What's happening? Guys, do you listen to me?
Yes, Miss.
Okay, it's not updating the it's not updating the drawing. Okay, let me do a different thing. Is that I have issues with my internet connection? Okay, I think it's ready. Okay, so this is what we have so far. Now, instead of the masses, what we're going to do is, remember, masses represent forces. That force, as you already said, is considered to be the weight. Okay? The weight is going upward or is it going downward?
Downward.
Downward.
So you're going to replace all the masses by an arrow that is going downward, okay? So instead of the mass 1, you're going to draw an arrow like that. Instead of the mass 2, you're gonna draw another arrow like that. And instead of the mass 3, you're gonna draw another arrow like that. Okay. Okay, now it's better. So now I'm going to label each force as force 1, force 2, and force 3. Okay, now take a look. Take a look here. Whenever the hinge is, draw a dash line. So the hinge is here. I will draw a dash line. So this will divide my drawing, my sketch, into parts, left and right side. Okay, left and right. So take a look now. Okay, now that you have all the forces placed, you have to put the lever arms. So my first lever arm comes from the first one to my hinge, right? Like that. So I'm just going to place it, sorry about it, in the right way. Wait. My first lever arm, that measures how much?
4 meters.
Okay. Remember, the definition of lever arm is, it is a perpendicular distance from the axis of rotation to an extension of the force in the place that it is applied. So what is the axis of rotation? What is the point where rotation occurs or that allows rotation? That point is known as the hinge. So that place, the hinge, is also known as the axis of rotation, okay? So the lever arm is the distance from the axis of rotation from the hinge to the force. So the lever arm 1 is the distance from the hinge to the force 1. Lever arm 2 is from the hinge to the force 2. Lever arm 3 from the hinge to the force 3. So that is what we're going to do. You're going to indicate the lever arms for each force. What is this lever arm? What is the distance here?
1.5 meter.
That is 1.5 meters. And I'm going to draw two possible lever arms, and you're going to choose which one is the right one. Option A and option B. What is the lever arm 3? Option A or option B?
Option
B.
B.
Option B.
B, because remember, it is the distance from the force to the hinge. So yes, as you said, it is the letter B. I'm gonna put it here. And it is the lever arm 3, but that measures 4.5 meters. Okay, that's the sketch so far. That's the sketch. You don't know the forces, but you know where they are placed and how the lever arms are. Now that you finish the step number 1, we're going to continue with the step number 2 that says calculate each force, that torque, and direction that each mass will cause. This is going to be my second step. Well, my second step, my third step, okay? Torque and direction are the third step. So I'm going to work with this process beside the exercise. So the step 2, wait, do you listen to me?
Yes, miss.
Okay, wait. Is that I have a problem with my connection? Ah, there it is. So in the second step, it says calculate each force. calculate each force. Okay. So what I'm gonna do now is calculating the force 1, force 2, and force 3. How? The force that depends on an object's mass is the weight. So this is going to be force 1 is going to be equal to the weight 1, and it's going to be equal to the formula, okay? That is mass times gravity, but not any mass. We're talking about object 1, so we need to indicate object 1. So it is mass 1 and gravity. Okay. Okay, it's going to be like that. So how much is this? My mass 1, that is 55 kilograms, and the gravity, that is 9.81 meters over second square. How much is that?
539.55.
What units are these?
500 is no 4.
Sorry. What units are these?
Newtons.
Newtons. That is correct. So now we got the first answer. Now we do the same for the force number 2. It is equal to the weight 2, and this is equal to mass 2 times gravity. Mass 2 is equal to 35 kilograms. And gravity that doesn't change is 9.81 meters over second square. How much is this?
343.35.
And the units are the same, Newton, because we are talking about a force. After this, we continue and calculate the third force. The force number 3 is equal to the weight number 3. And this is equal to the mass 3 times gravity. Mass 3, that is 10 kilograms, and gravity, that is 9.81 meter per second square. The total is equal to 98.1. And the units are Newton again. Now that we accomplish step number 2, we can say that we can calculate the torque. Okay, remember, step number 3 is, it says, calculate the torque. Okay, we are in this part. So that's what we're going to do. Step number 3 is equal to torque. Now, you have to know that every force creates a torque, okay? Torque is a consequence of every force applied that causes a rotation. Now, let me bring something from this. Okay. Yes. because this part, you can do it with your pencil, okay, to indicate, remember that you need to indicate the direction. Now take a look at that. I told you to draw a dashed line in the axis of rotation because of a reason. So take a look on this. For every force, you're going to determine the rotation. So what I do is I put the pencil in that position. Remember, the hinge is the eraser. So what happens if you apply a force? If you apply a force like this, what happens if you apply a force on that? What type of rotation are you going to have?
Counterclockwise.
Okay, let's see. Okay, I have this situation, and I think for you it's like this. I don't know, let me know. So you press it downward and you create a rotation. That rotation goes against the clock, which means it is counterclockwise. Entonces, for the first force, you notice that direction is counterclockwise. So I'm going to indicate the direction here. My torque 1 is equal to force 1 times lever arm 1 like this. Okay, my torque 1 is equal to force 1 times distance 1. Force 1 is 539.55 newtons. Where did I get it? From here. Force 1 equals 539. You can put it in the drawing. Okay, it's very useful you to do that. So I'm going to do it. My force 2 is 343.35 newtons, and the force 3 is 98.1 newtons. That's very useful if you do it like that, okay? So again, I'm going back to the formula of torque. So force 1 times lever arm 1, that is, what is the lever arm 1?
4 meters.
4 meters. So how much is this?
$2,015.82. No, it's 2,158.2. Sorry.
Okay. 0.2, and the units are Newton meter. Now, we need to indicate the direction. The direction that we noticed was counterclockwise. Is it positive or is it negative?
Positive.
Negative.
It is positive, okay? It is positive. Remember, if you apply this force, take a look to the pencil. If you apply this force, the rotation that you might cause is like this. So when you project it, you have this, okay? You can do it like the way I did it there, or in the other, it doesn't matter, okay? Both are positive. It is the same rotation, okay? It is the same rotation. So you can do it in one way or another. I prefer the first way because this other way looks more like a G. I don't know. But in any case, it is counterclockwise, okay? You can write CCW just to make sure. Now, that is positive. Now, the torque 2. Let's see what happens with the torque 2. Take a look. We already finished with the first one, so I'm going to delete this pencil. And now I'm going to work with the force number 2. So I'm going to put my pencil here. Remember, the hinge goes with the pencil. If you do this with the other force, in what direction is the pencil rotating? What direction is it going to cause right here?
Clockwise.
Here it is clockwise. If you want to take a look closer, this will be more like this. The pencil like this. So this is the same as having like this, and this is clockwise. Clockwise is considered to be positive or negative?
Negative.
Negative.
Clockwise is negative, okay? So we go and calculate the torque number 2. It is force 2 times the lever arm 2, and this is equal to 343.35 newtons. That is multiplying the lever arm 2. What is the lever arm 2?
1.5.
1.5 meters. How much is this?
515.025.
0.03 rounded. 515.03 rounded. I know. It stopped synchronizing. Okay, there it is. Now the units, remember, are Newton times meter. And the direction, we already got it from the pencil, and it is clockwise or negative. Clockwise. Remember, clockwise is negative. Now, let's get it for the torque 3, which is equal to force 3, distance, lever arm 3. My force 3, that is 98.1 Newton, and my lever arm 3, that is how much?
4.5 meters.
Okay, how much is this?
441.45.
441.45.
Yes.
Yes.
But we haven't seen the direction. So again, you're going to take your pencil and you're going to put it, you're going to hold it from the hinge, okay? And you're going to press in the same direction as the force is going, which is downward. What direction is the torque 3 going to have?
Clockwise.
Again, this direction is clockwise, therefore it is negative. Now, you can indicate your torque as being positive or negative with a symbol. Positive, negative, and negative. And will also be correct. But I prefer you to put the symbol to indicate if it's clockwise or counterclockwise. But you can do it in both ways. Now that you have all your individual torques, no sé por qué. Sale así, qué raro. That's what we do. But I have no idea why this is. Okay, yeah. Okay, like that. So now that you have all the torques, what comes next is to calculate. Take a look. We already got the force. You already got the torque and direction. So we're going to move to the next step. That is, calculate the net torque and tell the direction to which the object will finally rotate. So, to calculate the net torque, what you have to do, you just need to add the individual torques and also including the symbols. So in this case, the net torque is going to be equal to torque 1 plus torque 2 plus torque 3. Remember to consider the symbols. Positive torque 1, negative torque 2, and negative the torque 3. I don't know if we have the time. Let's see. Oh, yes, we had the time to do it. I didn't have the time to finish with the other section, so I thought the class was about to finish. So just replace and remember to write the the correct symbols, okay? So it is torque 1 positive 2,158.2 Newton meters. Torque 2 is negative, so you can write it negative here, minus 515.03 Newton meter. And also that torque number 3 is negative, okay? So put the negative here, 441.45 Newton meters. In what units your net torque is going to be written? How much you get? Guys, how much did you get?
1,201.72.
In what units do we express net torque? They are highlighted over there. You need to write always the units. The units are Newton meters. Now, the torque, is it positive or is it negative? What is the symbol that you got, positive or negative?
Positive.
Positive 1,201.72 Newton meter. Now, what is positive in rotation? Counterclockwise or clockwise?
Clockwise.